Welcome to second part of problems related to addition and multiplication theorem. Before proceeding ahead, we first recollect few theorems which are required in addition and multiplication theorem. First is the addition theorem. The addition theorem states that if A and B are two events, then probability of A union B, although we write this as union, this is read as OR. This is nothing but P of A, that is P of the first one, plus P of second one minus P of A intersection B. The union sign gets replaced by intersection. Although we write it as intersection, it is read as N. There is a similar formula for three sets, which says that P of A union B union C is P of A plus P of B plus P of C minus P of A intersection B minus P of B intersection C minus P of A intersection C plus P of A intersection B intersection C. So basically, formula is pretty simple to remember. You're writing all the singles with a plus sign. Then when you take the pairs, that is AB, BC, AC, you put a minus sign. And then when you write all three, you put a plus sign. There is multiplication theorem. Multiplication theorem says that the probability of A intersection B, which is read as A and B, has two formulas. One is P of A into P of B slash A. This is to be used in case of dependent events. And this formula, there's one more formula, P of A into P of B. This is to be used when the events are independent. Similarly, for three sets A, B, and C, probability of A intersection B intersection C is, for dependent case it is P of A into P of B slash A into P of C slash A intersection B. That means it is the first probability of the first event, then multiplied by probability of B, given that the first one has already occurred, probability of B, given that the first one has occurred, into probability of C, given that the first two, that is A and B, have occurred. This is to be used in case of dependent one, and there is one more, which is given by P of A into P of B into P of C, which is to be used in case of independent events. Now we proceed to solving a problem. John and Rahul answer an interview independently. We highlight this word first. John and Rahul answer the interview independently. Probability of John passing the interview is 2.5, while probability of Rahul passing the interview is 3.5. What is the probability that both pass the interview? We answer the first question. Probability that both pass the interview. So probability, first thing what is given to us is probability of John passing the interview, that is probability of John is 2 upon 5 and probability of Rahul is 3 upon 5. We ask probability that both pass the interview in the first sub question. Now both pass the interview means what? Probability that John passes and probability that Rahul passes. So this is N. John, when they say both have to pass, that is John and Rahul has to pass. Now there are two formulas again as stated over here. One for independent and one for dependent. So this actually resembles same thing. It's like here there is A and B, over here there is J and R. So since the word independent, we have to use one of these two formulas, either P of A into P of B by A, or we have to use P of A into P of B. Now this one is for dependent and this one is for independent. Now in the question there is word independently, which is why we use the second formula in this case. So this is using this formula, it is P of J multiplied by P of R. So P of J is nothing but 2 by 5 over here, and P of R is 3 by 5. So we get the answer as 6 upon 25. 3 2 is 6, 5 5 is 25. The next, it is said probability that at least one passes, and this is nothing but this is probability that John or Rahul passes. So when you say at least one, either one of the two has to pass, need not be both. So that is why this is probability of John union R, and this is easily given by the addition theorem. Probability of A union is P of A plus P of B minus P of A intersection B. In this case there is J and R, so this is nothing but P of J, that is the first one, plus P of R, that is the second one, minus P of J and R, J intersection R. So P of J is given to us as 2 by 5, P of R is given to us as 3 by R, 5, and P of J intersection R over here, we have found it as P of J is given here, P of R is given here, P of J intersection R is this, so this is 6 upon 25. When you try to make the denominator common, you get 5 upon 5 into 5 plus 3 into 5 upon 5 into 5 minus 6 upon 25. This is 10 upon 25 plus 15 upon 25 minus 6 upon 25, which is 19 upon 10 plus 15 minus 6 upon 25. This comes down to 19 upon 25. Now we move to the last one, that is probability that exactly one passes the interview. So when you say the third one is asking over here probability that exactly one will pass the interview. So exactly one passes. Now in this case, when you say exactly one, the following situation should happen. Now before this, we need some few basics clear. First thing, suppose if A is an event which says that it will rain today, it will rain, then A complement will denote it will not rain. It will not rain. In short, A complement will do exactly opposite of what A is doing. So suppose A is John passes, then A complement will be exactly opposite of what A does. So in this case, it will be John does not pass, and this is same as saying John fails. So the thing is, if you want to know or denote something negative, we have to use A complement. Now in this case, we come back to solving a problem. The problem is we are told to find the probability that exactly one passes the interview. Now exactly one passes. So in this case, what should happen is, if John passes, then Rahul must definitely fail. So it cannot happen that both of them pass or both of them have fail. So it should happen that exactly one of the two should pass. So if John passes, Rahul has to fail. Or it can also happen that John can fail, but in this case, definitely Rahul has to pass. So we are back to, so basically now this is the condition, or this is the explanation for the problem exactly one passes. What should happen is either John passes and Rahul fails, or it could also happen that John fails and Rahul passes. But in all, what should happen is only one of the two should pass. So this whole idea which we have written in English, that is John passes and Rahul fails, or John fails and Rahul passes, we write it using set theory. Now we say that J is John passes. So John fails is denoted by J complement, using the idea which I described earlier, that something negative is always denoted by complement. Similarly, Rahul passes, we denote it by R, and therefore Rahul fails will be denoted by R complement. So now therefore we want probability that exactly one passes. So we want the probability that John passes and Rahul fails, or we want John failing or Rahul passes. Now we use these set theoretic ideas. This is probability that John passes is denoted by J. Over here, John passes, if you observe, is denoted by J. This N, now N in set theory is denoted by intersection, and Rahul fails over here is denoted by R complement. Now this OR over here is replaced by union, and John fails is denoted by J complement, and the AND over here is replaced by intersection. Rahul passes is replaced by R. So we have converted all this English what we have written into maths. So John passes is denoted by J. This N is replaced by intersection. Rahul fails is denoted by R complement. Over here, this OR is replaced by union. John fails is replaced by J complement. And is replaced by intersection, and Rahul passes. Now we change the notation only to simplify our job. So we now call this part as A, and we call this part as B. This is just done to simplify our notation. So we get probability of A union B. So instead of this J and R complement, we have A, and instead of the J complement intersection R, we have B. This union is there as it is. Now we copy this part again. We are over here we have P of A union B. Now we know the formula for P of A union B. It is P of A plus P of B minus P of A intersection B. So now we replace this A by its original definition. So A in this case was J intersection R complement. So instead of this A we write J intersection R complement plus P of B. The P in this case was J complement intersection R. So we write instead of B here J complement intersection R, and then we write minus P of A. So instead of A we write J intersection R complement as suggested. This is A. There is the intersection of the formula which we insert here, and the B part over here is replaced by the other part which is J complement intersection R. Now, now we say that this is probability of J intersection R complement plus probability of J complement intersection R minus probability of J intersection R complement intersection J complement intersection R. Now we need to have a good understanding of English to solve this question further. Now this part says what? John passes, because it's just J, it is saying John passes. This is saying and this is also saying Rahul fails, and this intersection means N. Over here it is John fails. Again intersection means N, and this R over here means Rahul passes. So what is happening is the whole statement over here means nothing but John passes and Rahul fails, and John fails and Rahul passes. The problem with this statement is in the first it says that John passes and Rahul fails, but again it is saying that John fails and Rahul passes. Now it can never happen that a student who has failed can also that a student who has passed can also fail, and a student who has failed can also pass. So therefore, such an event that John passes and Rahul fails, and John fails and Rahul passes can never happen, and because it can never happen, the probability of such a thing is 0. So therefore, we are left with probability of J intersection R complement plus probability of J complement intersection R. Now, our goal is to find these two probabilities. So we take each of them. First, we target probability of J intersection R complement. So now probability of J intersection R complement. Since again this is like there is some first set A and there is some set B. This is like P of A intersection B. Now this is J and this is R complement. Now P of A intersection B, as discussed earlier, has two formulas. This is either P of A into P of B slash A, or we use P of A into P of B. This we use in case of independent event. Since our question contains the word independent, we use the formula P of A into P of B. Now what we do is we replace back. In this case, your A was J, so this A gets replaced by J. In this case, your B was R complement, so this we get it as P of R complement. Now the thing is, if you see your question, P of J is given to you as 2 by 5, which we insert over here, and P of R complement is not given to us. We are just given P of R. We are not given P of R complement. But we find P of R complement by using the following formula. P of R complement is 1 minus P of R. So we take 1 minus P of R is, if you look carefully, it's 3 by 5. So therefore, 1 minus 3 by 5 is 2 by 5, which we insert here, and therefore we get the answer as 4 by 25. 2 2s are 4, 5 5s are 25. So this answer we insert over here, so this becomes 4 by 29. So P of J intersection R is replaced by 4 by 29. Similarly, our job is to find P of J complement intersection R. So same idea we use. P of J complement intersection R will be, again, consider this part as A, consider this part as B. We get P of A intersection B. Since they are independent, we use the formula P of A multiplied by P of B. Now we recollect that P of A is nothing but J complement and B is nothing but R. Now probability of R is given in the question as 3 by 5, which we insert, but if you observe that probability of J complement is not given to us, we are given probability of J. So probability of J complement is not given to us, but probability of R is given as 3 by 5. Since we are given probability of J and not probability of J complement, we find probability of J complement using 1 minus probability of J. So probability of J complement is 1 minus probability of J. Probability of J is given as 2 by 5. So this answer will be 3 upon 5. You have to use cross multiplication. You multiply by 5, you get the answer as 5 upon 5 minus 2 upon 5, which is 5 minus 2 upon 5. Therefore, you get 3 upon 5. So this is again P of J complement is 3 upon 5 into 3 upon 5, which is 9 upon 25. So therefore, this is actually 9 upon 25. So similarly, now since both of them have a common denominator, we just write it as 4 upon 25 and we get this as 13 upon 25 as the answer. So now we have solved this problem when exactly one solves the problem. So this part is also done. Exactly one passes the interview. So the trick is pretty simple over here. Exactly one passes means John passes and Raul fails, or John fails and Raul passes. So then we convert this John passes into J, and whenever Raul fails something opposite or something negative, we write it as complement. This OR is replaced by union. John fails is written by complement, N is replaced by intersection, Raul passes is replaced by R. We use the replacement idea, then we use the addition theorem. We replace it back what was A, replace it back what was B, and we observe that such an event cannot happen, which is why the probability is 0. And then we find the probability of this and this using the discussed ideas. Now we come to the next problem. The next problem is a problem is given to 3 students A, B and C, and the chances of solving it are 1 by 2, 1 by 3, 1 by 4. If they solve the given problem independently, find the probability that the problem is solved. Probability that the problem is solved is, suppose, understand this concept this way. Suppose I give a problem to 3 students, the problem will become solved when either one of the 3 students solves it. Because the thing is, you did not want 2 students to solve it. It is okay if one of them solves the problem. So it is like the probability that the problem is solved is probability that anyone solves the problem. This is same as saying probability that A solves. So the problem is solved. Problem is solved is same as saying anyone solves is same as saying either A solves or B solves. Now why or? Because I don't want both of them to solve. As long as one solves is fine. Or C solves. So basically we want probability that the problem is solved is nothing but we want the probability of A solves, that is this or is replaced by union, B solves, this or is again replaced by union, and therefore C solved. Now there is a formula using addition theorem which we discussed over here. This is the problem. Probability of A union B union C is P of A plus P of B plus P of C minus P of A intersection B, B intersection C, C intersection C plus P of A intersection B intersection C. This is the formula which we want to solve this problem. So now we use that formula. We say this formula probability is equal to probability of A plus probability of B plus probability of C minus P of A and B, that is the two pairs, minus P of B intersection C minus P of A intersection C plus P of A intersection B intersection C. Now, we know P of A, which is given to us as probability that A solves the problem, over here is given as half. So P of A we are given as half. P of B similarly we are given as 1 by 3, and P of C we are given as 1 by 4. So P of A is half, P of B is 1 by 3, P of C is 1 by 4. Now our job is to find A intersection B, B intersection C, A intersection B plus P of A intersection B intersection C. Now we find probability of A intersection B. The first one. This has again two formulas. This is either P of A intersection B is nothing but this is either P of A multiplied by P of B given A has occurred, or we use the P of A into P of B formula. This is used in case of independent event. Now since the question has independent events, we use the second formula, so therefore this becomes P of A into P of B. P of A is given to us as half, P of B is given to us as 1 by 3. We insert both of them here and we get the answer as 1 by 6. So this is 1 upon 6. Similarly, we find P of B intersection C. So P of B intersection C will become P of B multiplied by P of C. P of B is nothing but, if you observe here, P of B is 1 by 3 and P of C is 1 by 4. So it is 1 by 3 into 1 by 4, which is 1 by 12. Next we find P of C intersection or A intersection C, which is required over here. A intersection C is required. So this is same as say P of A multiplied by P of C. P of A is 1 by 2. If you observe, P of A is 1 by 2. P of C is 1 by 4. So we get the answer as 1 upon 8. And the last we do it as P of A intersection of B intersection C. Using the same idea, we get it as P of A intersection P of B intersection P of C. P of A is 1 by 2, P of B is 1 by 3, P of C is 1 by 4. We get it as 1, 4, 2 into 3 is 6, 6 into 4 is 24. So we insert all these values. P of A intersection B is A intersection C is 1 by 8. This we found it as 1 by 24. Next we use a calculator and we divide 1 upon 2 is 0.5 using calculator. 1 upon 3 is 0.33. 1 upon 4 is 0.25. 1 upon 6 minus this minus sign is there. 1 upon 6 is 0.16. 1 upon 8 is minus 0.12 plus 1 upon 24 is 0.04. So when all these things are added, we get the answer as 0.76. Using calculator, when you add all these things, you should get the answer as 0.76. With this, we come to end of the part of problems involving addition and multiplication theorem.